All right, guys, in lesson 4 or 5 here, our I can statement is to be able to write equations to represent patterns and determine the number of solutions for equations. So we're going to look at a couple of different things here. We're going to start with some simple ones. We're looking at the example here. We're going to find the pattern, try to describe it in words, and then the new part of using a variable and write it in an equation that represents this pattern or shows it. So in the example, pretty easy one here. 4 plus 0 is 4. 17 plus 0 is 17. 243 plus 0 is 243. So to describe this, we would say the sum of any number. We know sum means addition. The sum of any number and 0 is always that number. Or I might write anything plus 0 always equals the same thing. All right, it keeps its own identity. That's just a simple identity property of addition. All right, so pretty easy to describe that and see what's going on in every one of these. The new part is to be able to generalize this now, and we have to be able to use a variable so to show that this works for any number. So notice the 0 stays the same in every one of these. What changes is the first number. So let's just call that p. So p could be any number plus 0 will always still equal p. Okay, so again, that's something you've known for a long time, but we're just kind of doing it with equations now and algebra with a variable. So now we generalize it to work for any number we plug in for p. All right, so again, that's the kind of stuff we're looking for to be able to do today. So let's look at question A here. I see 18 times 1 is 18. 2.75 times 1 is 2.75, and 6/10 times 1 is 6/10. Now this, I see that anything times 1 is itself. That's that identity property for multiplication. If I'm going to use language here that describes, using math language, I would say the product means multiply, the product of any number and 1 is always that number. Okay, so the product of any number and 1 is always that number. It stays the same, right? 18 times 1, it stays the same. It stays that number. It stays 18. All right, so again, a very easy identity property of multiplication here. The new part is now we need an equation that generalizes that, so it would work for any number. Okay, this time I'm going to call it, I don't want to use x because it looks like a multiplying sign. That's why they use the little asterisk here. But let's just use n for number. So we know n multiplied by 1 will always stay that number. So it will equal n. N times 1 equals n would there be my algebraic equation that I was able to write that follows this pattern. Guys, there are all kinds of different patterns, and you guys will have to start writing equations for those, and we'll get a little more complex than these, obviously, as we get going here. So that's the first part of what we're supposed to be doing today in our I can, and the next part is to try to determine the number of solutions that certain equations have. So I'm going to erase this and scroll down here, so we'll pause the video if you need to. All right, let's go all the way down here and look at number 3. For each equation, decide how many numbers will make the equation true. Okay, and we're just going to look at a couple of these, and then some you'll have to do on your practice slides to see if you can do it on your own. So let's look at number 3a here. It says 2 plus b equals b plus 2. When I see that, I know that's the commutative property. I know I just flipped them. And I know whatever I put in for b, all you're doing is adding 2 to it, no matter how you write it. So I know there's many solutions. Okay, we talk about the word evaluate or substitution as well. I could plug numbers in here. Let's say b is 4. So b has to be 4 over here. So if I plug it in, 2 plus 4 is 6. 4 plus 2 is 6. And guys, any number I substitute in there and then I evaluate this thing to see if it's true, you would find out every number you put in there works. There's not one number that won't because of that commutative property. So again, a pretty basic one, but we're just trying to see patterns and trying to think about how many solutions there are. Can I plug numbers in, substitute, and see if my thinking's true on that. Okay, let's just look at one more. Let's look at 3c. It says f take away 4 equals f take away 3. And again, my logic here, if f has to be the same, if I take away 4 from it, and then I take away 3 from it as well, they can never be the same. Okay, they're always going to be one different. Okay, so this one I'd say there's no solutions in this case. And if I wanted to plug in and prove it, let's say f is 10. 10 minus 4 is 6. 10 minus 3 is 7. Again, they are not equal. That would not be true. A number you need to try, usually zeros and ones, sometimes have some different rules to them or defy the rules a little bit sometimes. But again, the same thing. If you plug in those, they're always going to be one different. They'd be negative here in this case. But I usually try a couple of numbers. Always try 0 and 1, since sometimes those can work in certain situations when other numbers can't. All right, so you're going to look at a few as well here on your practice slides, trying to figure out how many solutions these things have and working on evaluating and substituting and plugging in numbers and getting practice with that type of thinking.